Let's see a non-standard visual proof for the sum of integers formula that has a byproduct of classifying odd squares mod 8. Imagine a triangular array of squares where there are n squares on the bottom like this. Such an array represents the sum of the first n positive integers, which can also be denoted in sigma notation as the sum where I ranges from 1 to n of I. Now let's take 8 copies of this triangular array, and let's rotate every other one of them, and then glue successive pairs together, forming 4 rectangles. Now we can strategically arrange these 4 rectangular arrays together to form a shape that is almost a square array. In fact, it is a square array with dimensions 2n plus 1 by 2n plus 1, but there's one square missing inside. This means that 8 times the sum of the first n positive integers must be 2n plus 1 squared minus 1. From this formula, we get 2 interesting consequences. First of all, we see that if we take 2n plus 1 squared, we get that that must be congruent to 1 mod 8, no matter what n is. Therefore, every odd square is congruent to 1 mod 8. On the other hand, we can also divide both sides of the equality by 8, and we see that the sum of the first n positive integers must be 2n plus 1 squared minus 1 all divided by 8. But then we can expand the numerator and simplify, obtaining the classic formula for the sum of the first n positive integers, which is n squared plus n divided by 2. To see a dozen other ways to prove the sum of the first n positive integers formula, check out the linked video. And don't forget to like and subscribe if you enjoy my animations of proofs without words.